Hey guys, can you guys see me? Hope you guys can see me. I'm just gonna plug in my earphones right now. If you guys can hear me, just let me know in the chat. I'm gonna hop on my phone and just see what's going on. Same. No one, okay. It doesn't matter. Honestly, like, it's 11 o'clock in the night. I don't expect anyone to be online right now. I'm just gonna go over to chat, see if I can access chat from here. There we go. Let me see if I can hear myself. Hello? Let me see if I can hear myself. Hello? That's pretty good, honestly. Yeah, that's decent. I'll take that. It's pretty damn good. Alright guys, so yeah, I'll just go over my solutions like soon, but for now, I'll wait for a bit. I'm just gonna relax for a bit, like. Welcome to us. See you next time. Open up warm up. Yeah, I'm just gonna submit the solution git add all git commit dash m added v423 solutions. So yeah, they should be up right now. If you guys can, let me just check them out myself actually. Oh shit. Oh wait, I forgot. Kind of stupid. Forgot to put this in there. No, I did not move in there. Here, let me. I'm just gonna like make this better, dude, because I physically cannot read a thing over here. All right, I'm gonna close this. Close this. All right, so I'm gonna move this in here. All right, boom. So now if I just here, what? Scheiße. Get out dot get commit dash m minor file directory mistake. Now if I look at this, boom, nice. So there. Solutions are up, guys. You guys can go check them out. Unfortunately, I only got to Q3 today, which kind of sucks. But we did finish strong. Finished 758. I was like 3 minutes late to the contest, so I somehow managed to clutch up. Finished Q4 in the first minute. So yeah. Yeah, dude. Q4 like was just like I had no chance of solving that thing, and that thing is just annoying. Q4 is absolutely annoying. Like I did not want to solve that one. But yeah, I'm gonna go like off for a bit, and I'm gonna write my editorial so you guys can take a look at it sometime. Yeah, I'm just gonna go offline for a bit, like maybe like a couple minutes, and then I'll write the editorial, like my explanations and stuff, and we can go over that. So. All right, I'm back. All right, great. I hope you guys can see this. What am I doing? Let me just go on my YouTube so I can see. Oh, I paused it. I don't know why. Okay, here we go. Let's get started. So, let's look at Q1 for now. And then we'll head on to Q2. I must say, I'm like really tired right now. But yeah, let's read Q1. It's a quite simple question, honestly. You have someone else in chat. Okay, anyways. Q1 is actually quite simple. It took like a minute or two for me to solve it. It's pretty good. Here it is. Given an array nums of n integers and integer k, determine whether there exist two adjacent subarrays of length k such that both subarrays are strictly increasing. Specifically, check if there are two subarrays starting at indices a and b, a less than b, where both subarrays boom, 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 boom. Right. Okay. So here, let me see if I can actually see, I'll see what he says. I'm gonna take a picture of this. And then I'll copy and paste this picture over here so you guys can read that. Right. Oh man, what am I doing? Increase that size a bit. There we go. Someone in chat. Oh nice, someone's watching. Great, anyways. Given an integer nums of n integers. So we know that len of nums is equal to n, right? Yeah, my handwriting is always slanted, but and we have an integer k. Determine whether there exist two adjacent subarrays. So meaning that in this array of n of let's say 1, 2, 3, 4, a subarray would be 1. This is a subarray because it's just part of the array. 1, 2 would be another subarray because it's also part of the array. 3 is another subarray. 3, 4 is a subarray. So technically speaking, 1, 2, and 3, 4 are subarrays. But here's the criteria. Exist two adjacent subarrays of length k. So when they give this, the len of subarray is equal to. So this is our condition. So it has to be equal to k. And they're strictly increasing, meaning that in any situation, so if I look at this one, in num of I, so in a subarray of I, I'm just going to say sub of I. Sub of I, so this current element must be less than sub of I plus 1. And this less than, not less than or equals to, right? That wouldn't work out because that means that it's not strictly increasing. It could be equal at times. So the strict increasing, so decreasing statement makes sure that it's a strictly increasing subarray. So if this is valid for every single element in the subarray, then we can say that it's a strictly increasing. Right? Makes sense? So yeah, if this is the condition, then we know it's strictly increasing, and they gave like, a little equation here, but that doesn't matter. And they must be adjacent, meaning that they must be side by side, and they said like, they give like a little equation like b is equal to a plus k, but you really don't need to care about that one. Just know that they're side by side. You have to return true if it's possible to find two such subarrays and false otherwise. So here, let's go to my code over here, and we'll go through it. It's really over the place right now, but whatever. Don't worry about these ones. This is just like a VS Code kind of thing because I didn't configure it well, but I don't care about that one. So yeah, we have our basic array over here. We have our method has increasing subarrays, which are going to take us to inputs, which is the list nums, and our integer k, which is the length of the subarray that is strictly increasing. And our goal, as we looked over, is to determine if there are two subarrays of length k that are strictly increasing. And a subarray is strictly increasing if each element is greater than the previous one. And we looked at that visual where it kind of explained how it works. So yeah, first step in our actual code is to check the length of our list. And this algorithm, what we're going to do is just iterate over the list starting from the index 0. And we're going to continue all the way to n minus 2 times k, because that's the one we needed. And that's going to ensure that our loop will have enough room in order to check for subarrays at length k at every single step. Right? So that's the iterating through the list part of it. After that, we're going to check if the array that we're looking at is currently a strictly increasing subarray. So for every single iteration, what we're going to do is going to check two subarrays. The first one is starting at index I and going all the way to I plus k. So the first sub is going to start off at index of I and go all the way up to I plus k. Oh man, what are these brackets, dude? What am I doing? Boom, I plus k. Makes sense? Right? This part. And we wrote a little helper function to check, Yeah, this is it. If nums get of I is greater than or equal to nums of get I plus 1, return false. Meaning that if it is equal to or if it's greater than the next element, meaning that if this condition that we wrote over here, which I need to find, if this condition is false, or, well, this is a new condition that my code set up, but here's how it works. If it's this, then we're just going to return false. Right? Because it makes sense. Because that means that our actual condition that we're looking for, if it's satisfied, then it is not a strictly increasing. It is probably a strictly decreasing, or it is decreasing in general. It has a decreasing order, or maybe it just doesn't have any order whatsoever, which is most likely the case when it's in this format. Okay. Let's go back to our code over here, and now we're going to check if our subarray that we're currently looking at is strictly increasing. And we're going to do that by comparing every single element with the next one. And if at any point that our current element is greater than or equal to the next one, then a subarray is not strictly increasing, which is this helper function over here. All right, and we're going to early exit if both of our subarrays are found. Right, if both of our subarrays are strictly increasing, then we're just going to exit, leave out of there, because we don't need to do any other computing. And if like by the time that we finish up our array, there is no matching subarray, then we have to return false, because it means that for our whole array, there is no match. And for this one, our efficiency would be O of n times k. Where n is a len of our list. So, I mean, n is equal to and k is equal to len of subarrays. Make sense? Because, when we're computing through it, when we're looking through it, we have to look for every single k element. There has to be 2 of them. So we go through all the elements and we look at every single k sections. Next up is our, so yeah, this makes sense. I hope this makes sense. If anyone has any questions, please let me know right now about the first question. I'm going to post that right now just in case you guys don't understand it. Okay. I'll give you guys a minute to think about that. And if there are no questions, let's move on. All right. 5, 4, 3, 2, 1. All right. I'm assuming that no one has any questions. It's just me and some other person. I'm currently on my phone right here, just checking chat, just to make sure I'm responding and there's no other new questions. And it says 2 people, so it's just me and someone else. I have no idea who the other person is. But yeah. All right, let's move on to Q2 now. Let me just get the Q2 solution right here. Wait, was that my Q3? No, that's not. I'm just delusional. Let's look at Q2, so we can understand what's going on over here. Bang. Q2. Boom. Yeah, so it's a similar question. I think it's just worse constraints or better constraints, quote unquote. Right? Let me just look at the 2 times n to the power 5 or 10 to the power 5, sorry. Yeah, it's not even close, dude. This one is just a lot more efficient. Yeah, there's no changes in this one, so it's just like it needs to be a lot more efficient one. Okay. You know, you guys get the logic for this one. If you guys understand the logic for this question, I'll let you take a look at it for like a second or two. Right. Oh, my face is covering something. Just realized. Okay, great. Let's move on. Since we already know how the question looks like and what they're looking for, let's just go straight into the solution. And I don't want light mode, so we're gonna go in dark mode over here. Let's zoom out so I can actually read this. And give me a second. Okay. Here we go. All right. So firstly, our function is going to check if our input nums is like if it's empty or if it contains less than 2 elements. In the case it does contain less than 2 elements, we cannot form 2 subarrays because a subarray has to have either 1 or more elements. So, you know, that kind of makes sense, right? I hope you guys understand that. If we have 2 or less elements, less than 2 elements, then we physically cannot form 2 subarrays. So in this case, in the case that any of these conditions are true, where it's either an empty, meaning it's null, or it has less than 2 elements, we can just like return 0 immediately because we know it's not possible. Okay. Wait, what? Wait a minute. That's what I wrote, yeah. Yeah, never mind. I'm just tweaking. So, okay, yeah, so we have our 2 helper arrays, which is what we're going to call left length, right length, and they're created in order to store information about the lengths of these strictly increasing subarrays. Yeah. And they are there to like store all the data and things about our strictly increasing subarrays. After which, our left length of I is going to store the length of the longest strictly increasing subarray that ends at index of I. Here we go. Yeah, so, what am I doing? Okay. If I have an array called, you know, it has elements 1, 2, 3, 4. Dude, I don't know what I'm doing. Okay, and let's say my subarray or my left line is going to look a little something like this, right? It's empty at the moment. So a subarray could be 1. That's a subarray. And it ends off at index 0. Right? So in the first element it's going to be 0 because that's where the first subarray ends off. And this one, this new subarray ends off at 1. This would be 2, 3. Because all the subarrays with the 4th element as this last one end off at the 3rd index. And the right length is the same, except it's going to talk about where it starts. So in this case, again, I would be 0. But let's say my subarray was 1, 2, but it ends off over here. Then my right one is going to have 1 over here. My left one is going to have 0, 0. Because this is our first subarray, and this is our second subarray, and our second subarray starts at index 0. And that's boom, right there. All right. Now that we have both our arrays that we need with a base value of 1 at their respective starting points, what we're going to do is, like now we know that any singular element by itself can form a strictly increasing subarray of length 1, since it's possible with this code that we've written. So now what we want to do is we're going to fill our left length array. We're going to fill it up with all the elements that we need. And that's going to start off with the second element. It's going to check if it's greater than the one before it. You know, that's our strictly increasing part of it. If it is greater than the one before it, then it's going to extend by adding 1 to the previous value in the left len array. If it's not greater, and it's going to reset to 1. The length is going to reset to 1. And this process is going to make sure that it populates all the way until yeah. I'm just looking at what I wrote over here for LeetCode. Just trying to make sure if I'm right or not. Yeah. Okay. Yeah. So this is going to ensure that our left len array is going to store the length of our longest increasing subarray that ends at every single index, which is what our left length array is meant to do. And now the right length array is just the opposite. It's going to populate all the way by adding 1 to the next value instead of the one before. Right? So it does the same thing that the left length array does, but in the opposite way. It's going to start off at the beginning again, but this time it's going to add 1 to the next element instead of the one before it, because now we're populating, right? And by doing so, I'm going to populate with all the length of the longest increasing subarray that starts at each index. Next step is the second last step is we're going to populate both arrays, and what we're going to do is we're going to look for the longest merge strictly increasing subarray that can be formed by combining 2 subarrays, one ending at index I and the other starting at index of I plus 1. So again, if I went to this over here, so this ends off at index of I, but this one starts off at index of I plus 1 and goes all the way up to I plus 2. Or R negative 1. Either one of them, doesn't matter. But yeah, that's what this is going to do. So we're going to find this maximum of our merged array. And finally, after we're doing all that, we're going to return our result, which is max of k. That's what it's going to return. And we return that because that's our maximum. Okay. So our time complexity is going to be O of n. Why did I write TS? I don't know why. TypeScript. Time complexity is equal to O of n. And n being the size of the input. Make sense? Why is you guys streaming so late? Oh, post-contest review. Just look at the... I'm going over the questions I just solved, so... Also, I think you're chronically online, I'm not gonna lie. I think you're always online. Are you chronically online? Yeah, and it's gonna, the space complexity is also gonna be... Nope, you're not? Okay, fair enough. It's gonna be O of n. And that's because it's gonna use 2 additional arrays. It's gonna use 2 arrays, which are the left length. Do it. You're gonna get on stream. Yeah, these are gonna be 2 arrays, and that's gonna be O of n because it's gonna increase in size based on the length of the array. And these are gonna have a len of n because they're gonna store every single index of the one that's starting and the one that's ending. And that's because they're going to store immediate results. Immediate results. Which are then going to be processed later on. That is the solution regarding Q2. I would say Q2 isn't that bad, honestly. I took a big hit on Q3. Oh, never mind. Oh, never mind. I took a big hit on Q2. What am I doing? Yeah, this is a lot. I had a 20-minute penalty. Good luck, Titus, with your history. Better get an A+. Yeah, but yeah, this one like really messed me up because it took me a whole 20 minutes for this one. Yeah, I hated that one. But Q4 is just even worse, man. I don't even want to talk about Q4. Alright, now let's set on to Q3. Boom. Q3. Q3 I'll explain a bit for, give me a second. Move it over to here. I'm going to put the question over here because it's a new question. Okay. Oh wait, where's my pen? Save to clip. Here we go. I'm going to shrink this. Okay. Okay. I'll read this out. We're given an integer array of nums. A good subsequence is defined as a subsequence of nums where the absolute difference between any two consecutive elements in the subsequence is exactly 1. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Return the sum of all possible good subsequences of nums. And since the answer may be very large, return it modulo 10 to the power of 9 plus 7. Note that a subsequence of size 1 is considered good by definition. Here we go. I'll explain the question. So first of all, we have our array nums. We can take nums anything. I'll take it as 1, 2, 3, 4. That's like the standard array that I always take. But yeah, this is going to be our nums array. And a subsequence just means that it's derived by deleting some elements or none at all without changing the order. So a subsequence could be 1, 3, because that means I'm removing 1 and 2. 1 and 2 are out of the scene. I mean 1 and 4, sorry. I mean 2 and 4. Oh my god, what am I saying? 1 and 3 is a valid subsequence because we're removing 2 and 4, but we're keeping the order of 1 and 3. If it was 3 and 1, however, this is not a valid subsequence because the order of the elements that they're put in is not the same. That's a subsequence. I hope that makes sense. And the thing is, 1, 2, 3, 4 is also a valid subsequence. 1, 2, 3, 4. This is also valid because the order is the same, right? 1 is first, 2 is second, 3 is third, and 4 is fourth. That's a valid, that's in the correct order they're supposed to be in. So that's a subsequence. That's a valid subsequence. Sorry, not a good subsequence. Now, a good subsequence is when the absolute difference between any two consecutive elements is exactly 1. Okay? So that means that, if I take 1 and 3 as our subsequence, the consecutive elements are 1 and 3. Right? 1, 3 are consecutive because they're right after each other. Now, the equation says that mod A minus B is equal to 1. And if this is true, in this case this is true, then this is a good subsequence. In the case that this equation, A minus B mod, or mod A minus B is equal to 1 is true, then it's considered a good subsequence. And that's what matters. That's all we need. But that's only if they're consecutive. First of all, we have to make sure they're consecutive. And before that, we have to make sure it's a valid subsequence. And then we have to make sure this equation is correct. So if we take a look at 1, 2, 3, 4, our consecutive elements are 1, 2. And 1 minus 2 mod is equal to 1. Right? Because 1 minus 2 is equal to negative 1. And mod of negative 1 is equal to 1. So this is going to be valid. So this is a good subsequence. So this is a good subsequence. Let's take a look at 3, 4. 3 minus 4 mod is equal to 1 because 3 minus 4 is equal to negative 1. And mod of negative 1 is equal to 1. Hence, 3, 4 is a valid or good subsequence. Sorry. So that's the question. And we have to return the sum of all our possible good subsequences. Ow. My ears kind of hurt. And what they mean by that is to take a look at all the elements. So if we look over here in this array, there is 3 good subsequences. There's 1, 2, 3, 4, and there's also 2 and 3. Right, because 2 minus 3 mod is equal 1. And that's because 2 minus 3 is equal to negative 1, and mod of negative 1 is equal to 1. Okay. So in this case, this is a good subsequence because it passes our test. So in this like small array, our good subsequences are 1, 2, 3, 4, and 2, 3. Write that down. 1, 2, 3, 4, and 2, 3. And what they want us to do is to add up all the elements. So 1 plus 2 plus 3 plus 4 plus 2 plus 3. Okay. 1 plus 2 is 3, 7, 5. All right. And this is going to be 15. So yeah, that's all they want us to do. They just want us to look at this. And we already know that even with such a small array, we already have such a big answer as 15. That's like a pretty big answer, honestly. In most test cases, you would never get 15 for any question as an answer. Maybe go up like 6 or 7. But yeah, we can clearly see how big it can get. Also, when these numbers are extremely large, like if it's 2, 4, 3, 6, 4, 8, 7, 8, and then the other one is like 2, 4, 3, 6, 4, 8, 7, 9. Right? This is already 2 big numbers. And since this is true, what's up, Aryan? Since this is true, adding these ones is going to be like give us an even larger number. That's going to be like a really big problem. That's why they want us to return modulo 10 to the 9 plus 7. That's what I wanted to return us. And like that says right here. 10 to the 9 plus 7. So yeah, let's walk through the code that I've written for Q3. This is Q2. Alright. Q3. There we go. Zoom out. There we go. Let me just do something. I'm just gonna look at my solution over here so I can get a bit of an understanding. I kind of forgot what I already wrote, so kind of bad. Okay. Here we go. Oh. My monitor unplugged. There we go. I can see now. Okay. This shouldn't be too hard. You guys see me? I hope so. Oh wait, you guys can't see the solution over here. I just realized. Okay, I'm gonna move my face. I'm gonna move my face. My face is right here. Make things better. All right, this should make things better. So now it's actually readable. I'm gonna zoom in. Is that better? Maybe. Yeah, that's a lot better. Wow. Okay, so we're gonna start off. So we looked at the question how it's gonna work, and here we go. Right. So first we're going to use our modulus value, which is 10 to the 9 plus 7. We're just going to comment this, man. 10 to the power of 9 plus 7. Makes sense? That's what it is. And this is our max value that we're going to work with. And this is like the maximum value that any element in our nums array can have, which is going to be 100,001. And this is only based on our problem constraints. In the case that they did not give us any problem constraints, like if they did not say that this element is not going to be 10 to the power of 5, then we would have no idea what the highest, like what the longest number would be, or what the biggest number would be that we're working with. So yeah, this is purely off the constraints, and it's important that, I always emphasize that, always look at your constraints, because that's where most of the stuff they're going to learn is going to be free. Like, if I look at Q2, there is absolutely no difference in Q2, like the question statement, and Q1. They're both exactly the same, except for the constraints, except the constraints. This has a lot more strict constraints. We can see that the indexes are going to be a lot bigger, meaning the length of the array itself is going to be a lot bigger, and the values itself are going to be even bigger. Same over here, right? This one is like a lot more easy going on you. It's just like the maximum is going to be 100 elements, right? And our k is going to be whatever this is, 2 times k in less than or equal to num dot length. Yeah, makes sense. I'm tweaking. Anyways, I cannot think right now. Yeah, here we go. Let's start off. Okay, yeah, so first we're going to like initialize two arrays, and count is going to be how many subsequences are at a particular value. So how many valid subsequences? So, we're going to check like, oh, is it in the correct order? Do they have the same elements? Are they missing any elements? If they are, if they're not, is it empty? Is it not? And then the second one, which is going to be our sum one, is going to store the sum for our subsequences that are ending at a particular value, which is what we're going to need. And our result variable is just going to accumulate our total sum of all our good subsequences. So that's our final value, right? I think we're going to return sum over here. Boom. Right here. So yeah, we return the result, which is going to be all the sums of our subsequences, good subsequences. All right, so first of all, I'm going to loop over our input array, which is nums. And we're going to iterate over every single element. So first of all, we're going to go to the subsequence count and the sum calculation, which for every single number, we're going to left count is going to store how many subsequences end with a value strictly smaller than num. That's right here. And then the right count is the opposite. It's going to be whichever ones begin strictly at that point. And then left sum is going to store all the subsequences, the sum of all the subsequences up to that point that end with a value smaller than num. And then the right sum does the opposite. It's going to store the sum of all the good subsequences from that point on. And then these values are then going to be used to compute our count and the sum of our subsequences that will end at the position num. Okay. Next up is going to update our count and sum arrays, which is right here. This is that part. So our count and num array is going to be updated by adding our new count to the current value. My ears hurt, like really bad. Ow, that hurts, like really bad. Anyways. And our sum of num array is going to be updated by adding the new sum value to our current value at num, which makes sense. I'm also going to post, I think I already posted the GitHub solutions. I'm going to link it actually right now. Let me link these solutions so anyone watching can see. Or let me just, if you want to take a look at them. Boom, that's right there. That should be the code. Or, yeah, it should be the solution. So just take a look at them if you ever need to. If you don't understand something, because, yeah, I'm really drained right now. So, like, I don't even have that much power to talk. But I kind of have to. My eyes hurt. But yeah, our result is going to be also updated by adding our new sum value to it. And this is going to be really, really large. And this is the part where our modulus and our mod is going to be used to make sure that our results do not overflow a stack. And the time complexity for this one is going to be O of n. where's my mouse? Time complexity is equal to O of n. And this n is going to be the size, which I hope makes sense. Right? And that's because we're going to iterate through our whole array, input array, once. And for every single element in that array, it's going to perform a constant number of operations. So that's going to be O of 1. But that's only for O of 1, only for the computations. I button it. Right? Our space complexity is going to change, and that's because we're going to use our two different arrays, our count array and our sum array, and which are each going to have a size of max value plus 2, which is around, like, you know, approximation is equal to 100,003. And this is going to store our intermediate results. Intermediate results. But our final space complexity is going to be O of max val. Which is, again, O of 103, or no, 100,003. 100,003, right? I think so. I think so. See, I forgot, man. I physically cannot think right now. Anyways, to summarize what we've written over here, we're just going to calculate the sum of all our subsequences of nums by using dynamic programming, right? I hope that rings a bell in your ears. Yeah. And for every single element, it's going to calculate how we can form valid subsequences based on our previous elements in nums and sum all their contributions. Our result is then returned by using mod of 10 to the power of 9 plus 7. And we know this works is because it's going to track our subsequences using our two separate arrays called count and sum, which we called over here. And that plays a part into our space complexity. So, yeah, that is the contest solutions. Explanation. For weekly 423. Yay. And I hope you guys enjoyed, right? And finish the day off with a singular match. A singular oats. Oh no, sorry, something. I'll take that one. Light it in. Why not? So dark tonight. Oh man, that's hard. is not like good in clip sense. Hey, 32 BB, that might be a high score. One of them.
Mój rap, skurwysynu, rap jest moją kokainą. Nie wszyscy to rozkminią, za ten rap wciąż nas winią. Koniak, nie wino, tak to idzie, to ulice. Wszyscy nas słyszycie i znów z rapem na szczycie.
Wait, oh my god, wait, 32 BB, oh my god. Wait. Moro. That's not what I mean. To that one person who's mother, thank you for watching.
See you next time.
Anyways, I'm not feeling it right now. But thank you for watching, guys. I hope you enjoyed the solutions. Hope it makes sense. If it didn't, yeah. But yeah, I hope you guys understood what I said over here. Hope you learned a thing or two. If not, that's fine. Eventually you learn. But GG's. Thanks for watching.